Our final speaker in this morning's session is Grant Ryan. I think he's also going to be talking about detecting animals, but perhaps at a slightly greater distance.
Kia ora. I've got a quick confession to make. Like Andy, I'm not a scientist. Maybe one step better, I'm a failed scientist. I started as a scientist. I had a bit more luck as an inventor and entrepreneur and engineer. So this is a bit of an engineering approach. I'll just take a very low-tech question to start off with, won't use something. How many people think we're actually going to be predator-free practically by 2050? Is anybody? That's not a bad number. I was just kind of curious, actually. So the way I got into this project was after the earthquakes in Christchurch, I moved to a little property out on Banks Peninsula, surrounded by bush, absolutely infested with possums and rats. Absolutely nailed them. In the next couple of years, I'm sure the bird volume went up, as much because of what the rest of the community was doing it. But I thought there's got to be a better way to know if it's actually going up or not, because the 5-minute bird counts really didn't work, non-objective. So we started having a think about how we can apply high technology. So the big core idea here is there's this massive amount of information technology that's being developed in the open source community. I was really curious how we could apply this. So what we wanted to do was have a way that we could measure the sound, get it up to the cloud so that there was a really objective way that we could actually analyse it. So this is just a modified cell phone. It's a little app. It turns on, takes the sound measurement, uploads it to the cloud. So we've got a systematic database, a really cheap, inexpensive way that anyone can start collecting. Because what we don't even know, is it getting better or worse, and at what rate, and at what places. So we don't really know objectively. And the cool thing about if you collect the data, it's like if you've got years worth of data, as soon as someone's got a better way to analyse it, they can go and put a TUI filter on it or anything like that. So this little cheap, inexpensive device we obviously call a cacophonometer, because it measures the cacophony. So the Cacophony Project came up because we wanted to really talk about what we're achieving, which is try and get the birdsong back. So we also chose that name because we wanted people to be able to think about and discuss what's the cacophony index in your area. Is it going up? Is it going down? And I remember after pitching this, even without the device, I remember overhearing someone talking about how bad the cacophony index was in their area and what they wanted to do to fix it. So we have a way that we can cheaply and easily measure it. And then because I'm inherently a little bit geeky, I started thinking how else we could use this technology. So the measuring is kind of one kind of cool thing about it, but what we want to do is think about how we can take it to the next stage and weaponize it, and obviously that's called a cacophonator. So that's just talking about the advantage of having good memory. So this, hopefully when you first looked at it, you say, this sounds crazy. Can we make trapping 80,000 times better? That's just crazy. And my goal here is just to convince you that it's not only crazy, it's not actually crazy in the slightest. So the thing with food-based lures is typically the animals can smell 3 to 5 metres, but they hear 10 times that distance at least. So in theory, a trap can cover 100 times the area. When you're using food or even smell-based lures, typically they have a finite life. If it's powered by solar power, in theory it can be powered for a lot longer than that. If we've got a trap that's based on, I'll explain how we do this, it can monitor not just rats, stoats and possums, it can also be modified to do goats and cats and hares and all sorts of things. And the other thing that absolutely blew me away is when we started doing this, is putting cameras in front of traps and just seeing how low the catch rate is. Some of the commonly sold traps, we're getting 100 times we'll see a predator for every 1 time it's caught. And I'm like, ooh. I spent a long time thinking I must be setting this up wrong, but apparently that's just the catch rate of a lot of these traps. So if you combine all that together, that's an awful lot of improvement. Now, we're really focused on using digital tools because digital is so important. If you can digitise it, it gets twice as good or half the price every 18 months. So this is just the first phase of it, which is an optimal camera so that we can see everything that's going on. So the existing trail cameras are designed for kind of pigs and deers and hunting, and so they actually miss a lot of the fast-moving predators. We have inside that other little box, we've got a little Raspberry Pi, which is a little computer that 12 years ago would have been a supercomputer. It's now $50, and it runs 2 cameras. It's got an infrared camera and a heat camera, And our goal is to try and get something that can see absolutely everything. Because we know we've had examples of even those trail cameras missing relatively slow-moving hedgehogs. We know they miss all sorts of things with ferrets and so we want to see everything. But obviously, I had a very cool video I was going to play, but couldn't quite get it working out. But I get teased by my wife because in the morning, the first thing I do is I check my little web page, and I can see basically 2 videos side by side of everything that happened last night on the traps that we've got monitored. So all of this uploads to the cloud. It's all designed so that it's all open source and using the best IT solutions. So obviously, manually going through all of that is never going to work, but the cool thing is that artificial intelligence is just getting that much easier. So it's not some amazing science project to do that now. These are kind of plug-and-play tools. It's pattern recognition. So we did a little project with the University of Canterbury, took 50 videos, rats, stoats, possums, and birds, put it through an algorithm, and can you tell the difference? Well, yes, you can. And so what we're trying to do now is optimize that so that we can do that with as little tech as possible, and then we can run that on the device in real time. So then we'll have a device that'll be able to tell us 100% exactly what's going on. So if you want to eliminate it all or understand everything, you have to be able to see everything. So that's what we're aiming to do with that. And then obviously the first stage we can do, don't worry about the details of this, is we can just put this in front of different traps and predators and we can see exactly how effective they are. Because we don't exactly know if we can't see everything, we don't even know how effective chew cards and tracking tunnels and all the other things are. So it's a very effective way that, again, we can use AI and you can say you can tag it as this is when the trap went off, this is when it worked, it didn't work. And so you can quickly hone in on how effective these different devices are. So some of the TIMS and good nature ones, we're getting as little as 1% catch rate, so we'll see 100 possums. One we've just done recently, which surprised the heck out of me, we're getting close to 100% catch rate with hedgehogs and live capture traps. So for whatever reason, they seem happy to always go into them and get caught. So very low data set, but the goal is that we can at least have a tool that we can very quickly, effectively work this out. So I just want to talk about digital lures. So one of the things the hardest thing is when you've got a reinvasion or a low population, because there's lots of food everywhere. But what's next on the list after you've got a full belly, a little bit of social interaction? And that has real advantages for the low barriers. It's very species specific. And there are lots of ways that if you can do it digitally with sound, as soon as anyone works out a slightly better way, you can update the traps. So you can evolve faster than predators. So you get to a point where you can know that it's in a beech forest in autumn on a full moon after a bit of rain, and you've heard a possum in the area, and here's the best lure to use. So it can be very highly adaptable. The other reason I quite like that is people say, hey Grant, what are you working on? And I say, I'm thinking quite a lot about possum erotica. So when you've got digital lures, the other cool thing about these digital lures is we've been experimenting with sounds of possums, and there we can actually detect at a distance. So we played a possum kind of crowing, and we could hear 50 metres away a response. In that case, it didn't lure it in, but we could tell at a distance that there was a possum there. It was quite funny because we had it on a loop, and it was doing it every couple of minutes, and I went out a couple of hours later, and our machine was crowing away, and this one was still trying to sound manly, crowing back, but it had like a croaky voice. It was like, but that's kind of cool because it gives us a way that we can potentially detect at a distance where we can play some certain sounds, wait for a response, use AI, work out, is there something in the area? If that is, then play a different thing, lure it into the trap, identify it 100%. And then I won't go through the details of this, but there's basically we've tried to set this up as a best breed open source project. So we're using, I won't go through the details of that. So the goal is that we're getting advice that can monitor 100% of things, get real data on what traps are working exactly why, rapidly test lots of these digital lures. So instead of taking years to test digital lures, you can have sound files with hundreds of different sound files, and you can play them out there and use big data to work out what works quickly. So you're doing things at hundreds or thousands of times the rate using digital technologies. And then the really fun part is when we can look at a kill method that doesn't involve them sticking their head in something. So there's some really interesting looking possibilities. I won't dig into that And there's lots of ways that scientists can obviously use these tools that'll be kind of pretty cool. I won't dig into that either. I really want to emphasise this Moore's law. So this is something that, as an audience, you'll have much better intuitive feel, but we still have a really poor intuitive feel of it. The idea that it can get twice as good or half the price every 18 months if it's digital. So it seems harder to start off with, but it's that trajectory matters. So we did a little project, and we said if we had a device that could identify lure and kill everything, and it was $20,000 now, and you had half the rate of the historical rate of progress, we'd be able to make New Zealand predator-free by 2040, which would be kind of cool, and I think we can. So the weird thing about the exponential thing is you go through an initial phase of disappointment where people say, Grant, how many possums are you killing, and can we have your device? And I'm like, well, no, because we're not doing much, but we're on this trajectory. So it's typically very disappointing to start off with, and so we're not achieving much in terms of killing anything at the moment, but if you make the effort of making sure it is digital to start off with and it's on that trajectory, it has that ability to get amazing quite quickly. And if you think about digital progress, 10 years ago, hardly any of us had smartphones. We're talking 33 years to 2050. We're going to do it way before then, I'm sure of it. The other thing is that we knew pretty early on that we weren't smart enough to do this ourselves. So we set this up with Dave Lane, who's New Zealand Chair of Open Source. And so it's a best practice open source project. And we've had all these contributors already, and we'll continue to have more. So it's all open and free. You can use any of it you like for doing whatever you like. And it's a really powerful way that some cool things have happened in the world around the internet. It's quite a cool thing that people do this, actually. It's kind of amazing. So imagine a little device that you've got, say it's the size of this fist, and you could have drones could drop a line of these in the forest, and they could identify, listen, and lure in and eliminate the whole lot, rats, stoats, possums, the whole lot. And then you don't need to leave them there for very long. And you can take that, the drones can come pick them up, reload the poison, whatever, bits and pieces, move them along, and you just get rid of the whole lot. Now, it's not going to necessarily happen exactly like that, but because we can conceive of that now, and the actual technical things, there's no big scientific discovery required to do that. It's just a whole lot of high-quality IT information engineering. I think I'm going to re-ask the question, how many people think we can do it by 2050? Oh, I don't think I convinced that many. We'll just do it and show you. So thanks for having me along, and if there's any questions, I don't know if we've got time for a question.
You've got time for questions.
Lunchtime, cool.
Oh, sorry. Yep, got a question.
I was just wondering if you had thought about applying your recognition of audio recordings to also bird detection, like kind of the opposite of the same equation. Like, have you been using them, or could you consider using it for detecting bird densities or populations?
So the cameras can also identify birds, potentially, because it's the same, it's a pattern recognition, if I heard your question correctly. And the sound part of it is really around the bird. We're hoping to collect the bird volume so we can see it going up and down via the sound, but the camera can also potentially do birds. It's a very general pattern recognition thing. If you tag enough things, it can learn, and it's getting better and easier, so.
Great. I think we'll call it.